Alright, this is a set of dimple dies that I will be making on the lathe shortly. I designed it in Fusion 360 just to get the parameters, and here's a little preview of what it will look like. The base of the die looks like this. It's got a taper and then a bore in there for aligning, as well as threads. The top has a 3/8 inch through hole to allow a bolt to go through, and this boss here is basically to align with the boss or the bore in the base. Here's the sketch that I created to make the base. Now it all looks a bit complicated, but it's mostly not critical. There are only a couple of dimensions that are critical, and the reason I did this was just to get the dimensions off a piece of paper. So the first dimension that I think is important is this diameter here. It's 1/2 inch on this calculation, but it's actually the diameter for the dimple to end up as. And this diameter here is going to be the half of 3/4 of an inch. So if it's for a 3/4 of an inch hole for the dimple die, and the dimple itself being an inch, this diameter is going to be an inch, and this diameter, the radius, is going to be 3/4 of an inch. Then I decided to go with a 60-degree angle on the taper, and by starting at 1 inch and ending it at 3/4 of an inch on the diameter, then this length gets calculated automatically. The dimensions will pan out very nicely. Once you've got the compound set, then this distance here will develop automatically. Alright, so I started with a stock that was 1.5 inches in diameter, so this is the radius of that stock. I decided to go with 0.9, or this could be 1 inch, for the total height of the base. And so from here, what we will do is we will go ahead and look at just the base itself. And so after the base was done, I went ahead, after the sketch was done, I went ahead and did a revolve operation on it, and then I did a hole operation, and I'm going to show how I did that. I just found the center point for the hole, and I selected hole type would be a simple hole, tapped. Well, it actually is going to be a tapped hole, but not that the machine or the Fusion 360 cares about it. The only reason why it's important is because we'll be able to get diameters off of it. So I told Fusion that it's going to be a 3/8/16 class 2B. Now for the top, I basically just took the sketch from the bottom and I did a project to get some of the points, like this black point here, here, here. These were all projected from the other sketch, and then I did an offset for this and this line, and I offset it by 1/16 of an inch. I also offset from the bottom up by 1/16 of an inch, but this boss here, this diameter, is going to be the same as it was for the bore, and in reality it'll be, you know, a couple of thou less. So at the time that we are machining it, and we will make it a couple of thou less. Again, the height of this 0.65 inches, it's not critical, but the important dimensions will be when you're starting. We'll start from this end and we'll turn in like this. This will be 0.2 inches, this will be 0.5 inches, and then the taper itself will just work itself out. And we will go ahead and finish the sketch, and here it is. Now once again, the top has a hole in it, and this hole is modeled here, and again I selected the central point for the top, made a hole. This time it's a simple hole, and it's not tapped, it is just a clearance hole, and I selected a hex head bolt, 3/8 inch size. I chose a close fit, and again the reason for doing that is not because we are using this to actually run a CNC program, but just to get some measurements. Okay, the next thing we're going to do is to create a drawing from it, because actually that's what's really going to help us in working. And so we'll go to File menu, New Drawing, From Design, click on that, and gives you some options, and it says Full Assembly. We want everything. Create New from Scratch, ASME for the US, and we'll do A 11 by 8.5 and select OK. And this creates a new drawing as well as a base view. So we'll go ahead and place that. After selecting OK on the menu, we can go ahead and open up this Dimple die, and I'm going to try to work on just the base alone. So we've got the base, and we will go ahead and create a projected view from the base. So the first view will be down this way, and the second view over here for what it's worth. Now we can go ahead and modify the base view. So first we'll double click on this, and from style we'll go to visible and hidden edges, and that'll show it for all of them. And for this particular one, we have to close, and then we'll reselect just this one, and we'll go ahead and do shaded for this one with hidden edges. Next we will go ahead and do some dimensions, because that's what we really need the drawing for. So first we'll click on dimensions, and we'll go ahead and measure the entire height, which is 0.9, and again this is not critical. Then the distance from here to here, which is 0.4, and the distance from here to here, which is 0.68. Then the next diameter in, which is the size of the dimple, which is 0.1 inch, bore, and here we are. And then finally the hole. So next we're going to go ahead and do dimensions. We'll do linear dimensions for this to this, 0.75, and from this to this it'll be 1 inch. But we want tolerances on this. This particular dimension, so escape, we'll double click on this, and it brings up another screen which shows how much precision you want. I think we do want to 3 points. We will add on a trailing 0, and we'll add tolerances. The tolerances will be a deviation off to one side. The upper limit can be 5 thou, and the lower tolerance should be 0. Next we're going to go ahead and create the drawing for the other component. So we will say another component, we'll place it here and click OK, and that brings up a new component, and this time we just want the top. So we'll click off the other one, and the same as before, we'll select this, and then we'll go up here to projected view and put down a projected view here, and just like a little reference view here, and done. Now I've already laid down some dimensions here, and we'll just review a few of these. This one should again be to 3 decimal places of precision, trailing zeros, and this too should have tolerances. Now it cannot be any bigger than 750, but it can be smaller. So the upper tolerance should be 0, and the lower tolerance, it cannot be any bigger. We could go down by say 5 thou. This dimension has to be more critical because this is where the taper will end, and so I'm going to make this 3 decimal points, and I'm going to say we want this tolerance to be plus minus 5 thou. And finally, another important dimension is this one here, which is where the taper meets the top. Alright, we're going to go ahead and start by facing off this 1144 1.5 inch round bar. Next we'll go ahead and spot drill this and chamfer this side. Next we'll use a 5/8 inch drill and go down about 0.5 inches. Through, make some chamfers. Alright, now we're going to go ahead and bore out the inside to 750 and go in for a depth of 0.5 inch. 20 thou depth of cut. All right, time to check the bore. The DRO says 700 and the mic says 703. Next check 729. Should have been 730. We will go ahead and shoot for 750. All right, we'll take that. Next, it's time to turn in the taper, and I'm going to zero this out over here at the edge, which is 1.5. And we want to go into 1 inch, give or take. Okay, I'm going to go ahead and bring the cross slide to the 1 inch mark, and that will be the final position we will return to. And so at the 1 inch mark, we're going to zero it. That's our X0. We will not move the carriage at all, and now all the movement will be done with the compound and the cross slide. The compound is set at 60 degrees. We'll come back about 20 thou at a time. And these cuts can be pretty rough. Got about 100 to go. We've got 20 thou left, and the final pass we'll do very slowly and carefully. Okay, the cross slide is back to 0. Done. Well, I have to say the taper feels very smooth. I'm going to clean up this edge just a tiny bit. It's really hard to know what to do with that. Maybe just use a little bit of emery cloth on there. Okay, feels good, feels smooth. Next we'll chamfer the hole. That's for the 3/8 inch thread, and then after that we'll go ahead and tap it. That looks pretty good. I may make it a little bit larger. All right, this is the worst tap I have, so I think we'll just get the the tap started, and then I'll probably finish it off in a vise. Okay, I believe the base is finished. Time to turn the upper die. We're going to go ahead and mark off a couple of spots. The first will be at 1/2 inch in, and then the second will be 0.2 inches further in. Next we'll go ahead and turn on the OD for 1/2 inch down to 0.928. Okay, let's see where we are. 981. Shoot for 948. Now to check the mating part. We can't check the mating part until we turn the taper down. Alright, well, we will just go by measurements. Okay, next we will aim for 750. Need to take a smidge off because this part needs to be, the boss needs to be 750 or under. We may have to finagle that a little bit later. Okay, now for the moment of truth. Time to turn the taper. I have marked this spot as X0 and Z0, and then we will turn the taper down all the way to that spot, and we will start here and work our way to this spot. We're going to be turning in reverse. Okay, the way this turning will work is that we will keep coming back on the boring bar until the tip of the boring bar just touches the mark, the 928 mark that we had reached previously by turning the diameter. Alright, once again going in reverse. We'll just take a moment to look at the different areas. You can see the point that we have reached on the upper end of the taper, and it's not quite to the diameter of 928 yet. And on this end, it is the boring bar is cutting its own relief. So we'll just keep going further and further in until we've got the tip of the boring bar touching the diameter where we want it to be. The boring bar has almost reached the flat that we have cut the diameter. Now I'm going to pull back until we have contact. And this should be our final taper. This relief here is perfectly fine. That's where the material should go into. I'm going to clean up this area a little bit, maybe run some emery paper there. Next we'll go ahead and spot drill and then put in a W drill through, which is 0.386. So here are the parts, the base and the top, and they do go together nicely. And here we are, nice dimple. The very end seems to have bent up a little bit, but this part looks good. The underside looks good as well. We've got full compression pretty much. Again, a very nice, very smooth dimple. $115, $116. So that's not too bad. I mean, it adds a fair amount of stiffness, no doubt. And it looks neat and clean. And this one is close to the edge, but the edge didn't bend up like on this side. I'm not sure why this one bent. I may not have compressed it fully right at the beginning. And we'll try this dimple for one last time. This was done with the previous attempt that I had made. And again, a very nice dimple. All right, now for something completely crazy. Well, I tried to create something, but it really didn't get very far. And we got a nice dimple. Again, nice dimple. Try a third one. And a very nice dimple. This guy is a little bit more, presumably because of the thickness of the material itself. Again, it doesn't go down very far. The material itself is 60 thou, so 62 thou. 60, 59. But again, in terms of strengthening the material, as a dimple is supposed to, it'll undoubtedly do the job. One will have to be careful with the rim on the outside, and I think the way around it might be to perhaps ease this edge a little bit.